Hi, everybody. I wanted to take a minute and just walk you through a complete analysis, a t-test analysis, just to show you my process and hopefully help you refine yours so you can understand exactly what we're doing and how to do it. So I've made up a scenario here where we wanted to test two methods of studying for a statistics exam. There's the cramming method, wherein a student will just start studying the night before the exam and cram as much information as they can and take it. And then the dependent variable is the exam scores. Then we have spaced practice. Spaced practice is the opposite of cramming. Instead of doing everything the night before, you start studying several days or even weeks before, and just add a little bit more, review constantly, and so on. So you spread out your practice time. Once again, these are the exam scores. So our null hypothesis is that study approach has no effect on exam scores. Our research hypothesis is that there is going to be a difference in exam scores. And I'm going to leave it just at that there will be a difference for our research hypothesis and not predict which type. That makes this a two-tailed test. And I will set our alpha to 0.05. So the first step in doing an independent samples t-test, because these are two different groups of students who studied using the different methods and then took the exam, is to get the descriptive statistics. So I'm going to enter them into my calculator here. I'm going to start with the cramming group. So we're going to enter a 72, and using my calculator, I just hit the sum plus button. Then an 81 and a 90. And an 84, and a 64, and a 73, 78, 70, 71, and 80. And we see there's an N of 10 students. There's 10 scores here. Okay, now I can just hit second and get X bar, or the mean. So I'll write the mean down. 76.3, so they got a middle B on the exam on average. And the standard deviation, I hit the second sample standard deviation button, and we get 7.70. So SD equals 7.70, and our N we already know is 10. Okay. Now, excuse me. Now let's go over to the space practice side. I'm going to clear my stat calculator and we'll enter those 10 scores. 92, 70, 74, 80, 85, 94, 83, 88, 91, and 86. Once again, our N is 10. And I can calculate the mean, or get the calculator to calculate the mean, equals 84.3 with a standard deviation of 7.79. I'm doing a little bit of rounding right there. And of course, we know our N is 10. So we have equal N's in both groups. All right, now I'm going to go ahead and for each group calculate the standard error of the means. Since I already have the standard deviation pulled up here, 7.79, I just have to divide by the square root of n, right? Remember, the standard error of the mean is the standard deviation divided by the square root of n. So the standard error of the mean is 7.79 divided by 10. I'm hitting a 10 down here, square rooted, and I hit equals, and we have a standard error equal to 2.46. 2.46. Now I'll do the same on this side. Our standard deviation was 7.7, and I can divide that by the square root of 10, which equals 2.43. So SEM equals 2.43. Okay, now we have all of the information that we need to start doing our analysis. Now you remember, this is part of my announcement that I made earlier in the week about that whole pooled error variance thing that our textbook uses. I'm going to do a shortcut around that. So the formula for the standard error of the mean for independent samples, if you remember, is the standard deviation squared divided by n, that's for group 1, plus the standard deviation squared for group 2 divided by the n of group 2 square rooted. So plugging in the proper numbers here, we're going to have 7.70 squared divided by 10 plus 7.79 squared divided by 10 square rooted. So let's plug that into our calculator. We have 7.70 squared divided by 10 equals 5.93. I'm going to add that to 7.79 squared divided by 10, 6.07, equals 11.99. And if I take the square root of that, we get 3.46. 3.46, okay? Now, I don't want to confuse you too much, but there is another shortcut way of doing this longer formula. It's not on your formula sheet, but I just want to show you that it works, is if we just square the individual standard errors of the mean, add them together and take the square root, we'll get the same answer. So for example, 2.43 squared is 5.90 plus 2.46 squared is 5.90. So we add those together, take the square root, we get 3.44, just a slight rounding difference. Okay, so it works both ways, but this is the formula that you have on your sheet. That's the standard error of the mean, or the denominator of the t-test. So now we can calculate t. T is the difference between the means. We're going to have, I'm going to make it a positive number, so I'll switch it around. 84.3 minus 76.3 divided by the standard error of the mean, or 3.46. So we have, plugging our numbers in, hopefully you can see this, 84, let me clear it all, 84.3 minus 76.3 equals 8, divided by 3.46. 8 divided by 3.46 equals 2.31. Okay, 2.31. So this is our calculated t value. Okay, the number of standard errors that these two means are apart from one another. So now we have to look up our critical value. Now our t critical value is based on the degrees of freedom. And I'll just make a side note here. The degrees of freedom are the degrees of freedom for each group added together. So we have 10 scores in the first group, n minus 1, 10 minus 1 is 9. And we have 10 scores in the second group. So 10 minus 1 is 9. 9 plus 9 equals 18. So if I look up in our t table, here we go. Now we have 18 degrees of freedom. This is the two-tailed test, as I said at the beginning. 18 degrees of freedom. Our critical value at the 0.05 level is 2.1009. So 2.1009. Comparing our calculated t of 2.31 to a critical value of 2.1009, we find that our calculated t is larger. And if our sample means are further apart than 2.1009, we say that this is significant. And so our t with 18 degrees of freedom equals 2.31. And the probability of getting a T this large by chance alone is less than 0.05, because this is the value at 0.05. This is further apart than that, so it's even more rare. Okay, so that concludes the t-test. I think I'll stop there on this video. Then I will make a separate video for the effect size and the confidence interval just to finish it up, okay? But that's how we would do the hypothesis test or the significance test for an independent samples T. Okay, I hope that was helpful.